All right, welcome back for another lesson on fractions. Here we're going to be adding and subtracting fractions with denominators that are multiples of the same number. So what that means is that the denominators are going to share common factors, but they're going to be different. So we have to think about that when we are adding. We can't simply just add our numerators if our denominators don't match. So in this first example here, these fractions have denominators that are multiples of the same number, but we notice that our denominators are not the same. We've got 1/2 and 1/4, so those are different. To add, you have to convert the fractions into equivalent fractions with the same denominator, and then you're going to add the numerators. So you have to ask yourself, well, the 1/4 is already in lowest terms. I can't really make this number any smaller, so I'll have to make the 1/2 bigger. So what number times 2 is going to equal 4? Well, you may say to yourself, well, that's 2. So what I'm going to write here, I'm going to show that I'm multiplying this bottom part by 2, and I'm also going to multiply the top by 2. So my denominator is multiplied by 2 and my numerator is multiplied by 2. I have to do this operation to both, or else it just doesn't work. And you have to have balance in math. So I'm just going to rewrite this. So I've got 2/4 plus 1/4. Well, hey, would you look at that? My denominators are the same, so I can go ahead and add my numerators now. 3/4. And we have this lovely picture diagram down here just to show that. You have 2/4 adding a fourth, and I'll just finish up the diagram here. You wind up with 1/4 plus 2/4 gives you 3/4. And you can see that 3 out of 4 of the squares are shaded in here. So it's similar to our last lesson. There's just an extra step involved. Oops. Okay, what about this one? We have 2/5 plus 3/10. We can't really make this 10 any smaller. We could divide the 10 by 2, but then what are we going to do with a 3? We're going to end up with a fraction inside of a fraction, and that's not very fun at all. So we should make this 5, or the 2/5 go into the 3/10. So what number times 5 equals 10? Well, you could say, oh, that's 2. So I'm going to do a similar operation where I'm going to multiply the top, the numerator, and the denominator by the same number. And let's see what we get. We've got 2 times 2 is 4, 5 times 2 is 10, plus 3/10. Perfect. Well, we're just going to write really close to this fish. 4 plus 3 equals 7. And our denominator always stays the same when we're adding and subtracting. So that equals 10. So I hope you understand and don't have confusion. When I say your denominators are always the same when you add and subtract, notice I didn't do any adding and subtracting back here. That is prohibited when your denominators aren't matching. You can't add and subtract. It's just it doesn't add up to be the same numbers. You're going to get mixed numbers and strange things. So you have to convert that denominator to match the other one in order to add and subtract. So once our denominators match, then I can go ahead and add. Otherwise, you have to find the equivalent fraction that's going to have a matching denominator. Okay, so now what I'm going to do, I've got my 4/10 and my 3/10. I'm going to be a little bit lazy. I'm just going to shade in 3 more. That's the 3 I just took from right here. So we've got 4 plus 3, that's 7 out of 10. And our story checks out. Great. Okay, what about this one? 1/3 plus 1/6. Okay, so it's easier to make, sometimes you want to make the numbers smaller, but when you're working with these tiny fractions where you have 1 in the numerator, I always find it's easier to go up to the bigger one. Plus you're multiplying and not dividing. Although the operations are very similar, I find some students just prefer to multiply, and that's okay. So we've got What number times 3 equals 6? Well, you might say that's 2, Miss N. I feel like this is a common trend here. Whatever you do to the denominator, you also have to do to the numerator. So let's rewrite our expression here. We have 2 all over 6 plus 1 all over 6. Let's do our denominator test. Our denominator is the same, so I can go ahead and write that. 2 plus 1 equals 3. Awesome. And our story checks out. We've got our nice diagram down here. This one's easy to draw. I didn't want to draw the 10. So we've got 1, 2, 6 plus 1, 6 gives you 3, 6. What's the equivalent fraction here? We can actually reduce this to smaller terms, right? Reducing to lowest terms is one of the better ways to write a fraction. This would always be considered a correct answer if we weren't asking for reduced terms, but you may be asked to reduce. So let's look for that common factor between 3 and 6. I can see that it is 3. I'm going to divide by 3, and I am getting 1 over 6. Pardon me, sorry. 1 over 2. 1 over 2. Great. So this is the best answer. Best answer. Whereas 3 out of 6, answer. 3 out of 6 is still correct. This is the best answer. Let's do another one. Okay, so we've got 5/8 plus 1/4. So let's dun dun dun. Yeah, let's, because 5, this is an lowest reduced forms. I don't want to, I could divide 8 by 2 to get 4, but then I'm dividing 5 by 2, and that doesn't give us a nice whole number. So let's not go there. Let's instead go bigger. So we're going to ask ourselves what number times 4 equals 8. That's 2. Whatever you do to the denominator, you have to do to the numerator. Okay, so let's rewrite that. We've got 5/8 plus our 2 over 8. Realize that 5 kind of looks like a 3, so I'm just going to rewrite that. My apologies. Okay, 5 plus 2, that's 7. And our denominator stays the same, so we can go ahead and write that. And our story checks out. Again, I'm not going to draw this diagram out of 8. I'm just going to shade these 2/8 right here into this diagram here. Okay, and we've got 4 plus 3, that equals 7 out of 8, and our story checks out. Little happy face. I like when I get questions right. Okay, we've got one more here. So we have 1/5 plus 7/10. Let's see here. So again, 7's kind of a gnarly number to deal with. So let's bring these ones up to the other number here versus dividing. I'm finding we're doing a lot of multiplying to get that equivalent fraction, but that's okay. Okay, so what number times 5 equals 10? That's 2. Okay. So we can rewrite this as 1 times 2 is 2. 5 times 2 is 10. Plus our 7/10. Our denominator is the same. That kind of looks like a fish. I think it's all the fish in this theme. They're starting to get to me. Our denominator stays the same. This number doesn't change when we're adding or subtracting. Okay? And then we have 2 plus 7, 9. Okay? And I'm just going to pull these two over here. And we have 5 plus 4 is 9/10. And we're done. Let's try this one here. Okay, so we've got 2/3 and 1/12. Well, let's bring these ones up. What number times 3 equals 12? Say to yourself, that's 4. Whatever you do to the bottom, you have to do to the top. And that gives us 8 over 12 plus 1 over 12. And we're ready to add. Our denominators match. We can write our 12 there. 8 plus 1 equals 9. Same thing. I'm just going to scribble that 1 that we added, and we have 1, 2, 3, 4, 5, 9. Yeah, 9 over 12 out of 12 in total. Okay, so that's it for adding fractions with denominators that have the same multiple. Our questions won't always be this straightforward. You might have instances where you have to find a greatest common factor and you have to change both of them. But right now we're just changing the one.